Alright, all of our lights have now been placed, our volumetric lights with no shadows, and I've gone ahead and rendered actually at 25%, so I have this image showing at 300%, so it's very pixelated, but it'll give you an idea of how those lights take effect and how it'll show that glow around the rest of the object. And then we still have our streaks in here, and actually right now we have an explosion right here, an explosion light right here, so you can see kind of that glow around the outside. This one's fading out at this point, and this one's just about midway. And what I've actually done was I didn't parent all of them to each specific light because some of the explosions are behind the planet. So when it's exploding behind the planet, we don't really need to add any of those lights just because those glows wouldn't really show up in the camera, and the streaks that we're going to have are going to be fine. So pretty much this back explosion up here, I didn't create a light for that just because it's being covered up by this part of the planet, and we will still get our streaks on the outside right here rendering with our ray tracing. And there's one thing I want to let you know, and that is this scene is going to take a very, very long time to render, and if I do it at full frame, it's probably going to take a couple of days. And especially if I have all the ray tracing options on, and right now I've actually gone ahead and for our debris objects I've taken the ray tracing off of that, so those are not casting shadows at all on any of the objects. And I've also reduced the influence of each of the lights on the objects of the planet right now, just so we can speed up rendering. The final, we'll probably turn those back on, but like I said, it's going to take a couple of days. So you really want to kind of get it right the first time, which is hard to do because it takes a lot of tweaking in order to get, especially with lighting, you're going to have to tweak it a lot, and you might even render it, take a couple of days, and you'll realize that it doesn't look the way you want it to, and you're going to have to go back and do some tweaking. And the best way to reduce that is if we select one of our lights, and just one of our main lights, without the ray tracing, and what we can do is go ahead and open up the Viper, and make sure we have our lighting properties open for it, and our volumetric lighting open, and we can render. I'm about to find out exactly where that is showing. Take a look at the envelope, and we can see that that specific light is showing at between 150 and 180. So I'm going to set it to 165 or around there, and render, and we can see that light right there. And this is a smaller explosion towards the bottom. But the best thing to do is, even though we have Viper on right now, and what it's doing is it's taking that last frame we rendered and sticking that kind of in the background. And if you want to get rid of that, what you can do is just save your scene, clear it out, reload it, and then start up without any background images in the Viper. Make sure you have the Viper turned off and just turn it on just for this volumetric light. And what you can do is just create a preview and just go to make preview and actually set it to the lowest value and just do make preview, and it'll go ahead and make sure we also have it on draft, and it'll render frame by frame. And of course there's really no action for this light until we hit 150 or so. But what that's going to do, I'm just going to talk while this is rendering, it's going to give you a preview of what's going to happen with that light, how it fades out, how it's going to show up, not necessarily how much it reacts with the other objects, but it'll give you an idea of how long that light is lasting, if you think it's going to last long enough or it's too short. And I'd go ahead and actually create a preview for each one of the lights just so you can take a look and see exactly how they're going to react before you go and make that initial render. Because like I said, it could take a couple of days and probably several hours per frame, if not more than, even a half a day possibly to render one frame. And that's one of the disadvantages of using hypervoxels. And on another tutorial I'll be showing other methods you can do with using hypervoxels, but also using image sequences to kind of get rid of that. And you can see right now it's starting to render that. And it comes in real quick and leaves, which is all we needed it to do. And once we have that part rendered, you can just push the escape key and then push play. Alright, and that was just a short little burst, and that's all we really need, because we just need kind of a filler in between the time that our... Actually, I'm going to stop this now. We need a filler for in between this explosion right here, because this is that bottom explosion down here. And before that other one kind of comes in with the ray tracing and starts shooting the rays. And in this one, it's not as important, just because we have our light is not really covered up by anything, and our main light is going to be this one right here. I'm pretty sure it's that one, and that one is not covered up at all during any part of the explosion. And so it's kind of mainly for these objects like up here, and when we're going to get that little bit of delay because of the ray tracing. But it's still good to have that extra light in there without ray tracing, just so we can get that nice glow around the rest of the object, and kind of like it's more of a glow on the lens of the camera, and we're pretty much looking for that kind of effect by doing that. So our scene is pretty much done. There's a few things we can add. If we want to add stars to the scene, the easiest way to do that is actually with 8.0. We have something in Modeler here, and we'll just switch over to that, and we'll create a new object. And if you go to Create, More, and select Star Sphere, this is going to create a sphere. It's pretty much just a star sphere, and it's a sphere with stars around the outer edges of the object, and it's going to take your points and convert them into 1-point polygons. And it's also several layers, and each one of these layers you can either set it up. If you select multi-layered object, what it'll do is it'll put it on each one of the layers. We don't need to do that, so we can turn that off. You can set the size of the sphere, and I'm just going to leave it at 100 right now, and then size it as I need to, but I think 100 meters is going to be fine, because our planet itself is only 3 meters in size. And what you can do is you're going to get a surface name for each one of these specific stars that we have right here, and what that's going to allow you to do is change the brightness of each one of the surfaces of the stars, so that it's not all one star being copied over and over. You can have some bright stars in there, and you can change for each surface how many stars you're going to want for each one of those surfaces. And depending on how many points you have for each section, it could take a long time for it to process all that. So if I click OK right now, and it's going to say a star sphere with 8312 will take a while to proceed anyway. I'm just going to click OK, because really it's not going to take too long. I am working on a 3 GHz computer, but I don't think it's going to take that long for many computers. And as you can see, it's already done. So that really didn't take too long. It's just a little warning Lightwave gave us that it may take a while. Although it did say it would take a while, it didn't. So now we have our star sphere, and it's completely hollow on the inside, and all of our stars are on the outside of the sphere. So all we can do, we can go ahead and just save that. And we're just going to call it star sphere. And go ahead and set that object into layout. And take a look at the perspective view. And as you can see, that's big enough. It's all on the outside. Of course, if we sized it down, we'd have more stars in the scene as well. So we can go ahead, if you want, and just make sure we're in the camera view. Actually, we can go to the perspective view, and that way we can see so we don't intersect. And make sure the star sphere is selected, and modify size, and we're just going to size it down. And since we have no movement, it doesn't matter how close they are to the object. The closer they are to the object, the stars will move more, and you really don't want them to move unless the camera is rotating. If you move the camera up and down, especially don't want the stars to move because they're supposed to be extremely far away. And normally you would create the sphere to be extremely far away, but we're going to leave it just on the outer bounds of the camera. And we are going to be adding a little bit of camera shake, just because especially if you're going to be doing big explosions, you're going to want to add a little bit of shake in the camera, as if the camera's kind of in the scene and not just, it'll get rid of our 3D effect that we have here. And now if we want to take a look at these stars, see, now we have all of our surfaces under star sphere, and we can pretty just make a generic surface for one of them and go and paste it on the rest, and then adjust luminosity for each one. And what we're going to do is take and bring it up to white, bring our luminosity up to 100%, and that's for that first set. So we can copy that and paste and just do that all the way down. And now what we can do is just slightly edit the color on some of these. And I'm just going to go with a grayscale set of stars. You could of course add colored ones, because of course in real life there are colored ones, but I don't want it to interfere with the scene too much, and maybe we'll add a little tint of blue in one of them, and maybe just a little bit of tint of red, just small tiny tints and not too much. It's going to kind of take over the object. And I want to make sure, actually turn off the glow, because we're no longer going to need that, and just want to make sure that that's not affecting anything that's going to happen here. And now, depending on the type of camera jitter you're going to want, this is a very complex explosion, although it could be a little more complex as far as how many pieces there are. There are quite a few, and how many sets of explosions there are in the explosion in whole depends on how many camera shakes you're really going to want. Are you going to want every single explosion to create a camera shake, or are you just going to want the bigger ones to create a little bit of shake in the camera? And there's two separate ways to create camera movement, and there's a plugin called Jolt, which is in the motion modifiers. So if we select the camera, hit M on the keyboard, and click Add Modifier, you can select Jolt. And what Jolt will do is you set a keyframe, you tell it what keyframe you want the camera shake to happen, and it'll automatically shake the camera. And that way, you don't have to go in and create custom keyframes for each one of the movements. So we can go ahead and use Jolt right now and just kind of set up exactly where we want our camera shakes to happen. And we're going to want a little bit of a shake, of course, it's going to have frame, let's do 32, because it's going to take a little bit of while. All the explosions happening at 30, it might take a few frames for that to reach the camera, as far as the kind of the sonic boom of it, to actually move the camera. And we'll open up Jolt. And Jolt's a pretty simple interface. We can go ahead and we'll set this to 32 and create key. And we'll set the duration. We'll do this one 6 frames. And you can set a light, a medium, or a heavy jolt. And we're just going to do a light. And actually that will go ahead and change all of our settings. So you can just use the presets right here. And there's also events you can set up for when a certain object reaches a certain position, you could have it camera jolt. But we're going to take a look and see what this does, just with this one on here. And we hit frame 32, and as you can see, we get a little bit of camera jolt right here. And it's not completely linear, so it will kind of fade out. And then we can have it shake again. Actually, we can kind of almost have like a continuous shake throughout the whole thing, but we want to increase it in certain areas. So actually, we'll go ahead and this jolt key at 32, we can change that to a medium jolt. because it is that first explosion, we have a lot of different pieces coming out. That is kind of a big effect. And we also have a little bit of a explosion right here, right next to the camera. So what we can do is we want that to start blowing up at, I think that's going to be like 85. So we'll set our jolt key at 85. It doesn't look like it's going to let us. Okay, and actually the reason that Jolt was only allowing us to go to our 60 frames is because we did not set our render options. So if we hold down Control and Shift, right mouse click, we can pull up our render options, and we have to make sure we set render our last frame to 210, and then we can go back to our camera motion options for Jolt, and as you can see, now we have the ability to go up a lot higher. Alright, so now we can go ahead and find our other keys. And we're going to have that this one causing a little bit of an explosion. And we want to start that one at 77. So we'll go to frame 77. We could just type it in, and we're going to create a key. And we're going to set this to a light jolt. And we're going to have that go actually 25 frames. So it's a subtle jolt, but it's lasting a little bit longer. And plus we have all these other pieces going off at the same time. And because of this big one coming off on the whole, pretty much the whole top section of the planet going off, we're going to do a heavy jolt on frame, let's do it on 102. So we'll set this to 102, create key, heavy, continue, and we also want to make one more. I think there's one other real explosion in there, and that's that small one on the bottom right there. And that one starts at 156. So set this to 156, create key, and we're going to do a light and continue. And now we have our camera shake without having to add any actual keys to the animation, and we can do it all with that plugin. Now, normally I like to add other processing effects. If we were to go to hold Control down, hit F8, and under processing, adding an image filter, we could add. I usually like to add film grain and things like that. And there's a lot of different tools in there to do that, but you want to make sure that you have a good render before you go and do some post-process. And pretty much what that means is when you're doing your render, if you adjust the film grain to the point where you have too much and you want to reduce it, then you're going to have to go and have to re-render the entire animation. So what I would suggest doing is actually when you do a render, render it out as images. So if we go to render options, actually no, that was it, render options, and we go to output files. Instead of doing save animation, we're going to do save RGB, and sometimes it's best to do that anyway. And if you save it as RGB, what you can do is select, I'll just cancel that right now, you can select what type of images you want, and it's going to go ahead and save 210 of those images and create an image sequence. And what you could do with that image sequence is go into the image editor and load that image sequence, and then once that comes up, you could set it to sequence, and then it'll automatically detect the frame numbers inside of the image files and create an animation. And then all you got to do is set your camera back to the same resolution that you had before, and you can go to compositing, and once that image is in there, let's say wood was the name of the image sequence, and it'll say sequence after it if it is one. You can just load that into the background image and then go and start doing your post-processing effects, and that way you can render it. You'll just be rendering images and not actual 3D geometry and hypervoxels and things that are going to take several days to render. And so you want to make sure you have a good clean cut version before you go and start converting. Plus, I also like to convert things to 24 frames per second. Of course, most people don't really have a video output at 24 frames per second. So if you do have a video editing card and you output at 30 frames, or actually it's 29.97, you can just convert to appear as 24 frames, and it can play back at 30. And that will give you a more cinematic effect too, because films, of course, are 24 frames per second and television is 30, and that's why there is a very large difference when you're watching a television and watching a film, and you can really see a difference between kind of the movement, and you can really point it out. So I like to stick with 24 frames per second, especially for explosions and things like that, because they look a lot better. But we're going to go ahead now and get started rendering this, and then we're going to show you the finished product after we let this render for a couple of days. And actually, for the camera size, or the output size, this is a bit large, and we're going to have to reduce this if we do plan on having a video output. And like I said, it really depends on your output settings. Right now we have it at 850 by 480, which is not really a set resolution for any medium, but it's what I like as far as the aspect ratio, and I'm just kind of using that for still frames right now. But if we're going to change this, we can grab one of our resolutions off a custom, and if we want, we can do kind of a widescreen. So we could do a D1 NTSC widescreen, which is actually fairly close aspect ratio to what we already have, so we really don't have to adjust anything too much. But that's going to render at 720 by 486 with a pixel aspect ratio of 1.2, and that's pretty much going to be 16 by 9. And most of the time, depending if you're going to be doing like a DV output, you'll actually go ahead and change that height to 480 and not 486. But we're going to leave it at the typical D1 resolution right now. And there's also a few other things I want to set up. As far as anti-aliasing on the entire image, with the new since 8.2 update, you get all these extra anti-aliasing features, which gives you a lot more control over how many passes you want. And considering the fact that we have such a large animation, or at least so much information in the scene that's going to take so long to render, we're just going to set that down to 2 pass, and we should be able to get a good effect off of 2 passes, because most of it's hypervoxels and volumetric lighting, which really doesn't need to be anti-aliased. And we've actually gone ahead and turned off the anti-aliasing for that as well, and I can show you how to do that if we pull up our effects panel using Control F6, and under the volumetrics tab you can turn on volumetric anti-aliasing, and that only really affects what's in here, and it doesn't affect our volumetric lighting. But we have that set to lower resolutions anyway, or at least lower quality for the outside explosions, and then the ray trace explosions, of course, are going to take a long time no matter what we do to it. But we can just turn off volumetric anti-aliasing for hypervoxels, because it renders really well without anti-aliasing. And we're going to go back to our camera, and our reconstruction filter, we can leave that at classic, and that's fine. But we also want to have motion blur, and because that's going to add a lot neater effect to the overall image, and it'll kind of blur things as they would typically be blurred. And right now we have our blur length set to 65, but I think that's going to be a little bit low, so we'll change it up to 85 and give it a render at that, and that way our debris objects will have a nice little blur on it, and so will our sparks that we've created, and our objects as they're rotating and whatnot, and it'll look a little bit more like film. And like I was saying, we don't want to render this any higher than D1 right now. We might even go ahead and just render it at 50% and show just that lower animation just to save up some time instead of doing a full render, which could take forever. But of course we're not going to be able to show this full screen because we have right now set to our screen is set to 1024 by 768 as far as full screen, because these are high definition tutorials, so we're not going to set that all the way. So if I do, or when we do show this, it'll probably be a lot smaller than it should actually be. I'm going to close this out, and now we're ready to start rendering. And if you haven't rendered anything before, we're going to do this as RGB files. So just click this, and then you can set your file name, select what type of images you want, and you could select JPEG. A lot of people like to select JPEGs because they're small images, but there are some huge problems with JPEG images, and the main is the compression. And the built-in algorithm into a JPEG image is actually destructive, and every time you edit a JPEG image, it will go ahead and recalculate that algorithm and recompress itself, and actually, if you continuously open a JPEG image and continue editing it for a couple of years, if you have it on your computer, check some JPEG images from that maybe you've taken from a digital camera a couple of years ago, or something you've created a couple of years ago, and take a look at it, and you'll notice that there's a lot of strange pixelation in there, because all the pixels will eventually just blend together and you'll get lots of big blocks in there. And so I really wouldn't suggest saving as JPEG. Bitmap 24 is usually pretty good. It keeps the file size down and still keeps very good resolution, depending on, like I said, your video output. A lot of even, high-end video outputs, you can get only 16-bit out of it. So 24 bitmap should be fine. Or if you really want to go up to a higher level, you can do RLAs, which are pretty good, and even Photoshop files, which could take up a lot. I wouldn't suggest doing HDR images because they could take up an awful lot of space, but TIFFs and TGAs are also real good for image sequences. Or probably a TGA 24 would probably be the best, and that'll keep your image size down, not creating it too large, and keep your quality there without any compression. And then when you're ready to render, just hit, make sure you have that checked, and we have our render last frame set to 210, frame step at 1, auto advance is on, rendering, we have ray trace shadows enabled. We can turn off extra ray trace optimization because we're not going to need it because there's no reflections. Multi-threading, if you have multiple processors, you can set that up, and then just hit F10 on the keyboard and you can start to render.